Hey guys, Mr. Thibodeau here. So, Lesson 16, U.S. Customary System, and Function Tables. I actually have a pretty interesting little thing to read about this as well we are going to be talking about probably in class when I get back, actually. So, so on Thursday, I'll go over a thing about the U.S. Customs System. Because the customary system for weights and measures, pounds, feet, all of that stuff is set for a specific reason. And I want to kind of give you guys a reason about it because I think it's very easy to get down on it and to just really like the metric system. And the metric system is probably preferable for a lot of reasons. But there's definitely some very solid reasons for using the older style. Okay. So I'm gonna write U.S. standard is what you'll hear a lot. Do your mental math, do your problem solving. So we'll talk about the U.S. customary system, which of course we inherited from England. Of course, England has ditched it now, but 60 ounces to a pound, 2,000 pounds to a ton. We have 12 inches to a foot. Ooh, let's try that again. Ooh, there we go. 12 inches to a foot, 3 feet to a yard, 1,760 yards to a mile, or 1,760 yards to a mile. That's one heck of a thing. And then 5,280 feet to a mile. Okay. So pretty interesting. How many feet? Well, like it says. So just kind of getting you used to this system, okay? It's definitely different than the nice base 10 system that metrics has, but there is a reason for it. Units of liquid measure, we have 8 ounces to a cup, 2 cups to a pint, 2 pints to a quart, 4 quarts to a gallon, okay? Not as nice as base 10, but still pretty easy. 1/2 and 4s and 2s. Okay. And now again, I'll go over why this system developed and what was very useful about it. Okay. This system, this one here, the Fahrenheit. Why is it 98.6 for normal body temperature? Because we messed up. That's why. This was supposed to be based on human temperature. They thought what they had was that at 100 would be your normal body temperature and 200 would be water boils. They didn't quite set it up right. So the Fahrenheit's a little bit of a messed up system. Celsius is based on when water freezes. So 0 is water freezing. As opposed to 32. So this system, Fahrenheit system, was supposed to be based off of a body temperature, with 100 being our temperature. Of course, they kind of messed that up. 68 to 71 is room temperature, depending on how you keep your room. Why, if our body temperature is 98.6, does it feel so hot when the air around us is 98.6? Well, that's our internal body temperature. Our internal body temperature is constantly leaking heat, right? We're losing heat out. And so our skin, the heat is leaving us, and we feel comfortable when that heat continues to leave. We don't want that heat to just bottle up forever. Our body is not used to that. It's not made for that. So we want the air to be considerably cooler than us, so that way we can lose that heat. When the air around us is as hot as we are, we're not able to lose any heat. And so we start to have some issues. Our body is not meant for it. Okay, we start to overheat. That's a little science fact for you. I think generally, though, I think all of this is pretty straightforward. The math is, anyway, even if it's confusing why we use it. So again, on Thursday, I'll go over the why. I do want you guys to know this pretty well for Thursday because we're going to be talking about it. Okay. I don't think there's any real issues you're going to run into here. For the practice set, let's go ahead and do let's do 7 through 13. That's kind of an odd one. 7 through 13, and then 14 through 30 even. Okay. All right, guys, so that's the work. And again, please remember, if you get stuck on any problem in the practice set, the written problems, the written practice, the mental math, anything at all, shoot me an email, and I'll make you a video to walk you through it. Okay. All right. Have a good one. See you Thursday.